Hi, I am Yusuf. First, I will quickly talk about the theory of our project, electron spin resonance. For an unpaired electron of hydrogen atom in its ground state, L equals 0, the magnetic dipole of electron is only due to its intrinsic angular momentum, namely spin. Under an external magnetic field, the field establishes the z direction. The potential energy of the dipole is given by this formula. Ms equals plus 1 over 2 corresponds to the higher potential energy state, and minus 1 over 2 corresponds to the lower potential energy state. If photons, whose energy is equal to the energy difference of these two states, are provided, the electrons in lower energy state could be excited to the higher potential energy state, and this phenomenon is called electron spin resonance. This is the schematic of our setup. Two parallel-oriented coils provide magnetic field to the sample. The RF circuit emits photons of constant frequency for the purpose of excitation. The magnetic field strength is varied until the absorptions or resonance occur. The absorptions causes the frequency of RF signals to shift slightly. And we also added second additional weak oscillatory magnetic field so that these shifts are modulated and became audible via radio software. So therefore, when the resonance happens, we can hear it.
Before running our setup, first I will demonstrate each component. Here is the computer power supply. It provides 12 volt to our setup. Here is the voltage regulator circuit. It down regulates 12 volt to any voltage value that we want by simply adjusting this knob. This varied voltage is supplied to these coils. These coils are parallel oriented so that the magnetic field between them is nearly uniform. Here is the sample. It includes the polymer TC and Q. It has unpaired electrons. Here is the RF circuit. It emits the RF signals, photons, that we use to excite the electrons in lower potential energy state to higher potential energy state. Here is the RF antenna. It's connected to the computer. By using this software, we analyze the RF signals. Here is the last part, modulation part. Via this phone app, we provide additional small oscillating electric voltage to these coils. Our setup is very sensitive to the external disturbances, and there are always radio and TV broadcasts that interfere with our RF signal. Therefore, we don't always get the chance of quality observation. Here's a one recording that we made earlier, and I will comment on it. When the energy gap due to the magnetic field just matches the energy of the photons, the resonance occurs, and this pattern belongs to the resonance situation. When the resonance occurs, due to the modulation, we hear a sound tone of 1.5 kHz. Here is red strip, our main RF signal, 49 MHz. These white strips are due to the modulation. Here we either turn off the modulation or vary the voltage so that no sound tone is heard. Here we again turn on the modulation. Here's what happens is we increase the modulation frequency so that the strips are widened. We also add a video of our setup while recording this. You can find it in the description.